Hello, in this video we'll be looking into the number system. Let us look into the types of number system. The first is decimals. Now we have all seen what decimals feels like, right? Decimals are basically numbers like 2.34, etc. Next we have binary. Binary are usually used as a code or as in what your computer understands. So it's in ones and in zeros. Next, we have octal. Octal comes from the word octa. Now, octa means 8. So, the numbers that are lesser than 8 are called octa, right? So, if there's a combination of numbers for let's say 3, 2, 4, this number has all the numbers lesser than 8, hence it comes under the octadecimal. Then we have the hexadecimal. Hexa is nothing but 16 over here, right? So all the numbers should be less than 16. Now, when it comes to decimals, the base value of any decimal is 10, okay? And you can write the decimal numbers from between 0 to 9. So the base value is 10 and the numbers that you can use are 0 to 9. When it comes to binary, the base value is 2, right? The base value is 2 and the numbers that you can use is 1 and 0. Octa, like I told you, is 8, which means the base value is 8 and the numbers you can use are from 0 to 7. Hexadecimal's base value is 16 and hence the numbers you can use are 0 to 15. But here is a twist. You use numbers 0 to 9 and after 9 the numbers are replaced with alphabets, that is 10, 11, 12, 13, 14 and 15 are nothing but A, B, C, D, E and F. So when we write the numbers that we can use in hexadecimal, we write it as 0 to 9 and A to F. Now let us look into the conversions. So first we'll start with converting binary numbers. Okay. So let's take an example of a binary number. Right. So let's take 1, 0, 1, 1, 0 for example, right? So now how do we write it out, right? So first let me give you a simple trick. So the base value of decimal is equal to 2, right? So we'll write 2 below all of these, right? And now we'll go with the reverse counting and put them as powers. So this is 2 to the power 0, to the power 1, 2 to the power 2, 3, 4 and 5. So these are the values of each of those digits. Now how do we find out what the decimal value of this will be? So it's pretty simple. We go by multiplying this binary digit into the value here. So this will become 0 into 2 to the power 0, which is nothing but 0 into 1 is equal to 0, right? Then over here we have 1 into 2 to the power 2, sorry 2 to the power 1, right? This will become 2. And then we have 1 into 2 to the power 2, which is nothing but 4. Then this will become 0 and 1 into 2 to the power 4, which is nothing but 16. And then lastly we have 1 into 2 to the power 5, which is nothing but 32. Now what we do is we add all the answers. So 0 plus 2 plus 4 plus 16 plus 32, and the addition of these numbers is equal to 54. So the decimal value of this conversion is 54. Now, if I take another example where these are in fractional, this is like a whole number, right? So what if there was a point or it was in fraction, right? So let's take an example of that. So here we'll just consider the same number and then we'll add a point, let's say 0.110, right? The same thing. So now what will it be? So we'll have the same step till here. For the whole number and the decimal, we'll calculate it separately. So this we had found out was 54. Now for decimal, what we are going to do is we are going to multiply it by the negative part, which is nothing but divide it, right? So 110, here it will become 2 to the, and also one thing to make sure that you remember is we do not start from 0 here, and also we don't start from the backwards. Over here we started numbering them from backwards, whereas here we started from here and we start from 1. So this goes -1, -2 and -3, right? So this will become 0. It will become 1 into 2 to the power minus 2, which is nothing but 1 by 4, which is nothing but 0.025, and this will become 1 into 2 to the power minus 1 is equal to 0.5. Now we add this, and the answer we get after adding this is 0.75, right? So this is the answer for the decimal value. So the total answer for this will become 54.75. This is the decimal value for this binary conversion, right? Now moving on to the next conversion. Let's go from octa to decimal. So now let's take an example again. Let's take an example. Octa means we have to make sure that the numbers are less than 8. So let's take an example of 561 maybe. Okay, so 561, and let's start with decimal. Okay, so it will cover both the parts. Now again in this we are going to solve it separately. Now octa has the base 8 to 8. So we'll write 8, 8, 8, 8, 8. Okay, so over here we start with 0, 1, 2, and over here we go -1, -2. So the rules are the same, there's no difference in the rules, it's just what the base value changes here, right? So now this will become 8 to the power 2 into 5, which is nothing but 320. This will become 48, and this is 0. So the addition for this is 369. Okay, so now if we didn't have this decimal part and we had only this, then we would simply write the answer as 369, then we would put in the bracket and 10. Why 10? Because we are converting it into decimal. Okay, so hence we the base of decimal is 10, that is why we mentioned 10 over here. Now since that there is a decimal, let's solve the decimal value, right? So we'll solve the decimal value the same way. This will become 8 into 4 into 8 to the power minus 2 and 3 into 8 to the power minus 1. This is 0.0625 and this is 0.375. On adding this we get 4375. Now the point is, where do we stop, right? So you can simply stop at 2 digits also. So the answer for this would be 369.4375 to the base 10. So this is how you convert octa to decimal. Okay, so now we are converting hexadecimal to decimal. So now the base value of hexadecimal is nothing but 16. So now let's take an example of 3A 6D.EF, right? Now A here is nothing but 10, D is 13, and E will become 14 and F will become 15, right? So now what we are going to do is the same here. We are going to write 16, 16, 16, -1, -2, 0, 1, 2, 3. Right? So now on solving these, we'll multiply 3 with 16 to the power 3 and A, that is nothing but 10. 10 into 16 to the power 2. So over here we'll get the value for around 14,957, right? And now if we solve the decimal value same ways, 16 to the power minus 2 into 14, and then we have 16 to the power minus 1 into 15. I'm sorry, this is 15, it's 14, right? Then on calculating, this will become, okay, this is 0 point 0.585, and this is 0.875, which will give us 0.933. So the final answer for this would be 14,957.933 in the decimal values. So this is how you write it when you convert into decimal. Thank you.